Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Today we are starting our audiobook for ASNZS 3000, 2018. This is the Australian and New Zealand wiring rules. In this session, we will look at the preface and explain what the standard is trying to do in a simple and easy way. This standard is made of two main parts, and they are published together as one document. Part 1 sets out the essential safety elements. These are the minimum safety requirements for any electrical installation. Part 1 also gives regulators in Australia and New Zealand another way to write their electrical safety rules, so they do not have to rely only on the old system based on ASNZS 3000. Part 1 has a number of aims. It can be used by itself in regulation, or used together with Part 2. It is written to be complete, so people do not need to move between Part 1 and Part 2 when reading it. It focuses on the safety outcomes we need to achieve, rather than prescribing every work method. The detailed work methods are in Part 2. Part 1 also creates the enforcement link to Part 2. If someone does not follow a work method written in Part 2, then they are not meeting the safety requirements of Part 1, unless they use another method that still gives the same level of safety. Part 1 also confirms the deemed to comply status of Part 2. If an installation is done following Part 2, then it is taken as complying with the safety requirements of Part 1. Part 1 also keeps the standard aligned with international rules, such as IEC 60364 for low-voltage installations. It also provides a way for designers or installers to propose alternative methods when the job needs something different from the standard approach. Now let's look at Part 2. Part 2 sets out the practical installation methods that are accepted as meeting the essential safety outcomes of Part 1. Part 2 can also be adopted directly into regulation, depending on how each regulator chooses to use it. Part 2 builds on all the requirements of Part 1 and adds extra requirements and recommendations to make compliance clearer. It also brings back useful requirements and examples from earlier editions, showing typical solutions that work well and meet safety expectations. Part 2 focuses on common, practical, and cost-effective methods that achieve safety without being overly conservative or complicated. It also uses more figures and examples to explain areas that people often find difficult, such as alternative overcurrent device locations, IP ratings, and access to switchboards. That completes the preface. In the next lesson, we will move into the first clause of the standard and continue building this audiobook step by step. Clause 1.1 is the scope. This standard sets out the requirements for the design, construction, and verification of electrical installations. It also covers the selection and installation of electrical equipment that forms part of an electrical installation. These requirements are here to protect people, animals, and property from electric shock, fire hazards, and physical injury. They apply when the installation is used with reasonable care and used for the purpose it was designed for. The standard also gives guidance so the installation works properly for its intended purpose, and so it can handle foreseeable issues such as temporary loss of supply. Now we move to Clause 1.2, which is the application of the standard. This standard can be used through legislation in each state and territory in Australia and in New Zealand, where the laws relate to electrical safety. It can also be used together with any extra legal requirements, exemptions, or restrictions. The main use of this standard is for electrical installations in any type of building or land that is supplied by electricity consumers. However, the standard may also be referenced in other areas of legislation that involve electrical installations, such as safety of workplaces. For example, work health and safety laws and related codes may require electrical installations to meet certain conditions. Safe design and construction of buildings. This may include national building codes, such as the National Construction Code, and in New Zealand the NZBC. It also links to other reference standards that support building safety. Electricity generation, transmission, and distribution systems. Safe connection to electricity distribution systems. For example, service rules or conditions set by local electricity distributors. Qualifications of electricity workers. Part 1 of this standard gives a way to accept design and installation practices that may not be covered by the methods in Part 2, which includes sections 2 to 8. This is only meant to be used when the change from the normal Part 2 method is significant. Part 2 still has a certain amount of flexibility built into it. Clause 1.3 refers to documents used by this standard. Appendix A contains the full list of reference documents. Now we are moving into Clause 1.4, which is the definitions section of ASNZS 3000, 2018. This part explains how certain words are used in the standard, and it helps us understand the rules correctly. Clause 1.4.1 is the application of definitions. Throughout this standard, the definitions listed from Clause 1.4.2 to Clause 1.4.134 apply. If a term is defined in a particular place in the standard, then that definition applies for that specific section. These definitions apply to both parts of the standard. If the context does not require a special meaning, or the word is not specifically defined, then the common, everyday meaning is used. When the standard talks about voltage and current without any other description, it is talking about RMS values. Clause 1.4.2 is the definition of accessible. This means something can be reached for inspection, maintenance, or repair, but it does not include having to take apart parts of the building in a destructive way. Clause 1.4.3 is accessible, readily. This means it can be reached quickly, without climbing over things or removing obstructions, and without needing a movable ladder. It also means the item must not be more than 2.0 meters above the ground, the floor, or the platform. Clause 1.4.4 is accessory. This includes devices such as switches, fuses, plugs, socket outlets, lamp holders, adapters or ceiling roses that are part of wiring, fittings, luminaires, switchboards, or appliances. It does not include the lamps, the luminaires, the appliances, or the switchboards themselves. Clause 1.4.5 is active, also called active conductor. An active conductor is any conductor that is at a different potential from the neutral or the earthed conductor. In a system where there is no neutral or no earthed conductor, every conductor is treated as an active conductor. Clause 1.4.6 is adjacent. This means next to, or touching, without obstruction, and within arm's reach. Clause 1.4.7 is aerial conductor. This is any stranded conductor, including aerial bundled conductors, that is supported by insulators or purpose-made fittings above the ground, and is directly exposed to the weather. Clause 1.4.8 is alteration. This means a change to part or parts of an electrical installation. Repairs are not alterations. Repairs have their own definition in Clause 1.4.101. Clause 1.4.9 is appliance. This is any device, other than a lamp, where electricity is turned into heat, motion, light, or some other form of energy, or where the electrical properties are changed. Clause 1.4.10 is appliance, fixed. This is an appliance that is fastened to something, or secured in a fixed location. Clause 1.4.11 is appliance, handheld. This is a portable appliance designed to be held in the hand during normal use, with the motor, if it has one, forming part of the appliance. Clause 1.4.12 is appliance, portable. This is an appliance that can be moved while it is operating, or one that can be moved easily from one place to another even when it is connected to the supply. Clause 1.4.13 is appliance, stationary. This is either a fixed appliance or an appliance that weighs more than 18 kilograms and does not have a carrying handle. Clause 1.4.14 is arc fault detection device. This is a device that detects arcing faults within the installation wiring or the plug and lead connection of electrical equipment. When an arc fault is detected, the device disconnects the circuit. Clause 1.4.15 is area, hazardous. This is an area where an explosive atmosphere is present, or may be present, in amounts that require special precautions in the design, installation, and use of equipment. Clause 1.4.16 is arm's reach. This is the zone a person can reach by extending their arm from any point where they normally stand or move. It means the distance a person can reach by hand in any direction, without using tools or a ladder. Clause 1.4.17 is authority, regulatory. This is the government agency responsible for the relevant legislation and how it is applied. Clause 1.4.18 is authorized person. This means the person in charge of the premises, or a competent person appointed or selected by that person, to carry out certain duties on the premises. Clause 1.4.19 is available, readily. This means something can be reached for inspection, maintenance, or repairs without having to dismantle structural parts, cupboards, benches, or similar items. Clause 1.4.20 is barrier. This is something that provides basic protection from access. Basic insulation and basic protection are explained later in the standard. Clause 1.4.21 is cable. A cable is either a single cable core, or two or more cable cores laid up together, and it may or may not have fillings, reinforcement, or protective covering around it. Clause 1.4.22 is cable, armored. This is a cable that has a wrapping of metal, usually tapes or wires, and the purpose is to give mechanical protection. Clause 1.4.23 is cable core. This is the conductor along with its insulation, but it does not include any mechanical protective covering. Clause 1.4.24 is cable, flexible. A flexible cable is a cable where the conductors, the insulation, and their overall covering are designed to provide flexibility. Clause 1.4.25 is cable, mineral insulated metal sheath, sometimes called MIMS. This is a cable where the insulation is compressed powdered mineral inside a solid drawn metal sheath. The cable may be single-core or multi-core. Clause 1.4.26 is cable, neutral screened. This is a cable with one or more cores laid together with or without fillers, surrounded by a concentric wire outer conductor, and then further protected with an insulating sheath. Clause 1.4.27 is cable, sheathed. This is simply a cable with a core or cores covered by a sheath. Clause 1.4.28 is ceiling, suspended. A suspended ceiling, according to ASNZS 2785, is a ceiling system that hangs down from the floor or roof above. It does not include a nailed timber ceiling following AS/NZS 2589 or timber building standards. Clause 1.4.29 is circuit. A circuit includes live conductors, protective conductors if they are present, a protective device, and the associated switchgear, control gear, and accessories. Clause 1.4.30 is circuit breaker. A circuit breaker is a switch that opens a circuit automatically when certain conditions happen, such as an overcurrent, an undervoltage, or some other external control. Clause 1.4.31 is Class 1 equipment. This is equipment where protection from electric shock does not rely only on basic insulation. It also has another layer of safety because accessible conductive parts are connected to the protective earthing conductor. This ensures that if the basic insulation fails, those parts cannot become live. Clause 1.4.32 is Class 2 equipment. This is equipment where protection from electric shock does not rely only on basic insulation, but includes extra measures such as double insulation or reinforced insulation. There is no need for earthing or installation conditions to provide the protection. Class 2 equipment may include equipment made with durable, Continuous insulation that surrounds all metal parts, except for small parts such as screws or nameplates. Or equipment made with a continuous metal enclosure where double insulation is used throughout, except for parts where double insulation cannot be practically done. There are also types that combine these two methods. Clause 1.4.33 is Class 3 equipment. This is equipment where protection from electric shock relies on supply at SELV levels, and the equipment never generates voltages higher than SELV. If the equipment contains circuits above SELV, but those circuits are isolated and meet other safety rules, they are not considered part of the Class 3 equipment. Clause 1.4.34 is competent person. This is someone who has the knowledge and skill to perform the required task correctly. This knowledge and skill may come from training, qualification, experience, or a combination of these. Clause 1.4.35 is conductor. A conductor is a wire or other material suitable for carrying current. It does not include metallic parts that are only used to enclose electrical energy or provide structural support. Clause 1.4.36 is conductor, bare. This is a conductor without covering or insulation. Clause 1.4.37 is consumer mains. These are the conductors between the point of supply and the main switchboard. Clause 1.4.38 is contact, direct. This means touching a conductor or a conductive part that is live in normal service. Clause 1.4.39 is contact, indirect. This is touching a conductive part that is not normally live, but has become live because of a fault, such as insulation failure or some other fault condition. Clause 1.4.40 is cord, flexible. A flexible cord is a flexible cable where no wire is larger than 0.31 mm in diameter, and no conductor is larger than 4 square millimeters. A flexible cord must also have no more than 5 cores. Clause 1.4.41 is current, fault. This is current that flows because of an insulation failure or because insulation has been bridged or broken down. Clause 1.4.42 is current, overload. This is an overcurrent that happens in a circuit that is otherwise electrically sound. Clause 1.4.43 is current, short circuit. This is a fault current that results from a fault of very low impedance between live conductors under normal operating conditions. The fault path may include the path from the active to the neutral conductor. This is also known as the prospective short circuit current or the bolted fault. Unless stated otherwise, this value is the three-phase RMS value at the relevant point in the installation. Clause 1.4.44 is damp situation. This is a situation where moisture is present all the time or appears from time to time in a way that would reduce the effectiveness or safety of an electrical installation that meets the standard for ordinary conditions. Clause 1.4.45 is de-energized. This means separated from all sources of supply, but not necessarily isolated, earth, or out of commission. Clause 1.4.46 is distribution board. This is a switchboard that is not the main switchboard. The definition links to distributor, electricity in Clause 1.4.57. Domestic electrical installation in Clause 1.4.53. Double insulation in Clause 1.4.73. Clause 1.4.47 is earth. This means connected to the general mass of Earth, and when it is relevant, also connected to the supply neutral as required by the standard. Clause 1.4.48 is Earth's situation. This is a situation where there is a reasonable chance that a person might touch exposed conductive parts while also touching Earth or some other conducting medium that allows a circuit to be completed to Earth. The following cases are considered Earth situations. Item A. Within 2.5 meters in any direction from a conductive floor, such as concrete, tile, or brickwork, or from a permanently damp surface, or from metallic conduit, pipe, or cable sheath, or any other conductive material on which a person may stand. Item B. External to a building. However, a piece of equipment mounted more than 2.5 meters above the ground and away from exposed conductive parts that are in contact with Earth is not considered to be in an Earth situation. Item C. within 2.5 meters of the ground, floor, or platform in rooms that contain socket outlets, where the earthing terminals are earth, and where there is a reasonable chance that someone could make contact at the same time with any exposed conductive part of electrical equipment or any exposed conductive part of an appliance connected to any socket outlet. Item D. All parts of a bathroom, a laundry, a lavatory, a toilet, or a kitchen. Clause 1.4.49 is earth fault loop impedance. This is the impedance of the earth fault current loop, meaning the active to earth loop, starting and ending at the point of the earth fault. The earth fault current loop includes the earthing conductor and the protective earthing conductor. Clause 1.4.50 is electrical equipment. This includes wiring systems, switchgear, control gear, accessories, appliances, luminaires and fittings used for purposes such as generation, conversion, storage, transmission, distribution, or use of electrical energy. Clause 1.4.51 is electrical fault. This is an electrical failure, defect, or flaw in equipment or wiring, or any condition that results in an unintentional loss, reduction or increase of current or voltage, or where voltage exceeds the maximum rated value. Clause 1.4.52 is electrical installation. This is electrical equipment installed to convey, control, measure, or use electricity. It includes equipment supplied from a distributor's system or from a private generating system. It normally starts at the point of supply and ends at the point where fixed wiring stops, or at a plug or socket outlet used to connect appliances. Clause 1.4.53 is electrical installation domestic. This refers to an electrical installation in a private dwelling, or the part of an electrical installation that serves only a flat or living unit. Clause 1.4.54 is electrical installation multiple. This is an installation that includes a number of domestic electrical installations, or a number of non-domestic installations, or any combination of domestic and non-domestic installations. Clause 1.4.55 is electrical installation residential. This is an electrical installation, or part of an installation, that is associated with a living unit or units. Clause 1.4.56 is electric vehicle, often shortened to EV. This is any vehicle powered by an electric motor that draws power from a rechargeable storage battery, and that can be used on public or private roads. This includes plug-in hybrid electric vehicles, where the motor draws some or all of its energy from onboard batteries. Clause 1.4.57 is electricity distributor. This is any person or organization that supplies electricity from a distribution system to one or more electrical installations. It includes a distributor, a supply authority, a network operator, a local network service provider, an electricity retailer, or an electricity entity, depending on the jurisdiction. Clause 1.4.58 is enclosure. An enclosure is a part that provides an appropriate degree of protection for equipment against external influences and against accidental contact with live parts. Clause 1.4.59 is energized. This means connected to a source of electrical supply. A piece of equipment or wiring that is energized has voltage present. Clause 1.4.60 is equipotential bonding. This is the use of electrical connections to bring exposed conductive parts or extraneous conductive parts to the same, or nearly the same, potential. It is not intended to carry current during normal service, but it helps reduce the risk of electric shock under fault conditions. Clause 1.4.61 is explosive atmosphere. This is a mixture under normal atmospheric conditions where flammable substances such as gas, vapor, dust, fibers, or flyings are present, and can ignite and sustain an explosion. This definition follows ASNZS 60079. Clause 1.4.62 is exposed conductive part. This is a conductive part of electrical equipment that Item A. Can be touched with the standard test finger as specified in AS/NZS 3100, and Item B. Is not a live part, but may become live if basic insulation fails. There are exceptions where the term does not apply. These include conductive parts inside an enclosure where a key or tool is needed to open it. Conductive parts inside equipment that cannot be touched in normal use or during normal movement of the equipment. Conductive parts that are separated from live parts by double insulation or by conductive parts that are already earthed. Clause 1.4.63 is extraneous conductive part. This is a conductive part that is not part of the electrical installation, but that can be at the electrical potential of the local earth. Examples include metal water or gas pipes, heating system pipes, metal building components, steel-framed structures, reinforced concrete floors or walls, tiled surface coverings, conductive fittings in bathrooms, and metal pipes. Clause 1.4.64 is fault current limiter. This is a device, designed or selected, to open a circuit in order to limit the instantaneous fault current. Clause 1.4.65 is fire mode. This refers to a specific mode of operation in building systems that is triggered when a fire alarm activates. It changes the behavior of equipment or systems to suit emergency conditions. Clause 1.4.66 is functional earthing, often shortened to FE. This is an earthing arrangement provided to ensure correct operation of electrical equipment, or to allow reliable and proper functioning of electrical installations. Clean or low-noise earths used for electrical equipment may also be considered functional earthing. Clause 1.4.67 is functional unit. This is a part of a switchboard assembly that includes all the electrical and mechanical elements needed to perform one complete function. Conductors connected externally, such as auxiliary cables, are not considered part of the functional unit. Clause 1.4.68 is fuse. A fuse is a device that protects a circuit from excessive current by melting its fuse element and opening the circuit. A fuse includes all the parts that form the protective device. Clause 1.4.69 is informative. This means the content is for information and guidance only. It is not a mandatory requirement. Clause 1.4.70 is ingress protection classification, also called IP classification. This is the degree of protection provided by an enclosure, following AS 60529. Clause 1.4.71 is installation coupler. This is a connecting device, following ASNZS 61535, that consists of an installation socket and an installation plug. It is designed for permanent connection and is not intended to be engaged or disengaged under load. Clause 1.4.72 is insulated. Insulated means separated from adjacent conducting material by a non-conducting substance or airspace that provides resistance to current flow or prevents dangerous discharge. It is used to avoid shock or dangerous leakage of current. Clause 1.4.73 is insulation system. This is a system of insulation around live parts. It may consist of one or more layers that cannot be tested separately as basic or supplementary insulation. Clause 1.4.74 is isolated. This means separated from all possible sources of electrical energy and made incapable of being energized unintentionally. Clause 1.4.75 is isolation, also called isolating function. This is a function intended to cut off supply to the whole installation, or to a section of it, by separating it from every source of electrical energy for safety reasons. Clause 1.4.76 is lamp. A lamp is a bulb, a tube, or similar item that produces light from electricity. Clause 1.4.77 is lift. A lift is an apparatus attached to a building or structure, where a car or platform travels between vertical guides to raise or lower people. It does not include hoists, dumbwaiters, escalators, or travelators. Clause 1.4.78 is live. Live means energized, or subject to hazardous induced or capacitive voltages. Clause 1.4.79 is live part. A live part is a conductor or conductive part that is energized in normal use. This includes neutral conductors and conductive parts connected to a neutral conductor. There are exceptions. The following are not considered live parts. Earthing conductors. The MEN connection and the neutral bar or link at that point. A neutral bar or link in a switchboard that has no MEN connection when the active supply has been isolated. The sheath of an MIMS cable and associated fittings used as a combined protective earth and neutral conductor in an earth sheath return system. Supports and enclosures associated with unprotected consumers mains that are earthed according to Clause 5.5.3.5. A submain neutral conductor or final subcircuit neutral conductor where the active supply to that submain or subcircuit has been isolated. Clause 1.4.80 is luminaire, also called light fitting. A luminaire is a complete lighting assembly designed to distribute or filter light from one or more lamps. It includes components such as shades, diffusers, starters, and ballasts. It includes the means of connecting to supply, wiring, and support. A lighting component not incorporated into the assembly is not considered a luminaire. Clause 1.4.81 is main earthing conductor. This is the conductor that connects the main earthing connection or bar to the earth electrode, or to the earthing system of the electrical supply. Clause 1.4.82 is main switch. This is a switch whose primary function is to isolate the electrical installation from the supply. It may also meet regulatory requirements if it is labeled properly. Clause 1.4.83 is multiple earthed neutral, also called MEN system. This is an earthing system where parts of an installation that need to be earthed are connected to the general mass of earth and also connected to the neutral conductor of the supply or the PEN conductor. Within the installation, the protective earthing conductor is separated from the neutral conductor. Clause 1.4.84 is neutral, also called neutral conductor or mid-wire. This is the conductor of a multi-wire or three-wire system that is maintained at an intermediate and stable potential relative to the active conductors. It is the conductor connected to earth at the origin of the supply. Clause 1.4.85 is neutral earth system. This is a system in which the protective earth and neutral conductors from the transformer or generator to the installation are not connected together anywhere except at the transformer or generator. Clause 1.4.86 is normative. Normative means the item is a required part of the standard and must be met to claim compliance. Clause 1.4.87 is obstacle. An obstacle is a part that prevents accidental direct contact, but does not prevent intentional direct contact. Clause 1.4.88 is outbuilding, individual. This is a structure containing a switchboard that is separated by an area of land from the structure that contains the switchboard supplying it. Clause 1.4.89 is outbuilding, combined. This means two or more structures installed or built on the same foundation, or sharing conductive metal roofing or conductive metal frames. These structures have more than one electrical supply and are separated by an area of land from another structure that contains the switchboard from which those electrical supplies are taken. Clause 1.4.90 is overcurrent. This is any current that exceeds the rated value of electrical equipment. For conductors, the rated value is their current carrying capacity. Clause 1.4.91 is plug. A plug is a device made to insert into a socket outlet, a cord extension socket, or an adapter. It allows a detachable connection between the accessory and the flexible cord or cable. Clause 1.4.92 is point in wiring. This is a termination of installation wiring that is intended for connecting electricity-consuming equipment. Clause 1.4.93 is point of attachment. This is the point where aerial conductors of a service line, or aerial consumer mains, are attached to the consumer's building or structure. Clause 1.4.94 is point of entry. This is the point where the consumer mains or the underground service cable enters a building or structure. Clause 1.4.95 is point of supply. This is the junction of the consumer mains with either item A, the conductors of an electricity distribution system, or item B, the output terminals of an electricity generating system on the premises. Clause 1.4.96 is protected extra low voltage, also written as PELV. This is an extra low voltage system that is not electrically separated from earth, but still meets all the requirements of SELV. Clause 1.4.97 is protection, basic. This means protection against dangers that come from direct contact with live parts of the installation. Clause 1.4.98 is protection, fault. This means protection from dangers that arise from indirect contact. This is when someone touches an exposed conductive part that is not normally live, but has become live due to a fault such as insulation failure or some other issue. Clause 1.4.99 is protective earth neutral, also called PEN. This is where the neutral and protective earth functions are combined in one single conductor. Clause 1.4.100 is protective earthing conductor. This is an earthing conductor, other than the main earthing conductor, that is intended to carry earth fault currents or to connect parts of the installation to the earthing system so they are safely earthed. It links to terms such as a CD, readily accessible, readily available, regulatory authority, and reinforced insulation. Clause 1.4.101 is repair. This is work done to restore the electrical installation to a safe and sound condition after damage or deterioration has occurred. Clause 1.4.102 is residual current device, also known as a CD. An ASCD is a device that disconnects the supply to protected circuits, socket outlets, or equipment when it detects a current flowing to earth that exceeds a set value. Clause 1.4.103 is ripple-free DC. This applies to sinusoidal ripple voltage where the ripple content does not exceed 10% RMS. Clause 1.4.104 is safety service. A safety service is a system or component that operates during an emergency and is mainly associated with helping people evacuate a building, supporting firefighting operations, or providing fire suppression. Examples include fire detection systems, smoke control systems, evacuation systems, and emergency lifts. Clause 1.4.105 is separated extra low voltage, also called SELV. This is an extra low voltage system that is electrically separated from earth and from other systems so that a single fault cannot give rise to an electric shock. Clause 1.4.106 is service protective device. This is a fuse or circuit breaker installed as required by the electricity distributor for interrupting the supply to a consumer's electrical installation from the supply main. Clause 1.4.107 is shall. Shall indicates a mandatory requirement. Clause 1.4.108 is should. Should indicates a recommendation. Clause 1.4.109 is socket, cord extension. This is a device made to attach to a flexible cord. It has contacts that allow a detachable connection with the pins of a plug. Clause 1.4.110 is socket outlet. This is a device fixed or suspended at a point and having contacts that make a detachable connection with a plug. A cord extension socket attached to a flexible cord that is permanently connected to installation wiring is also considered a socket outlet. Clause 1.4.111 is socket outlet, multiple combination. This is a socket outlet with two or more sets of contacts that allow detachable connections with two or more plugs. Clause 1.4.112 is socket residual current device, or SRCD. An SRCD may be a fixed socket outlet that includes an integral RCD. Or it may be a separate RCD installed next to the socket outlet. An SRCD may or may not have overcurrent protection. Some SRCDs also allow RCD protection for downstream socket outlets. Clause 1.4.113 is soft wiring. Soft wiring is wiring that uses installation couplers installed as part of a subcircuit or as part of a submain system within an installation. Clause 1.4.114 is source of supply. This refers to the generator, converter, transformer, or a group of generators or transformers that are connected to supply mains and that provide electrical energy to an installation. Clause 1.4.115 is subcircuit, final. A final subcircuit is a circuit that starts at a switchboard and supplies only consuming devices or points. Its origin is considered to be at the neutral bar or link, or at the load terminals of the circuit protective devices provided for the circuit. The circuit ends at the supply terminals of the consuming devices or points. Clause 1.4.116 is submains. A submain is a circuit that starts at a switchboard and supplies another switchboard. Its origin is also taken to be the neutral bar or link, or the load terminals of the circuit protective devices provided within the switchboard that feeds the submains. Its termination is taken to be the supply terminals of the other switchboard. Clause 1.4.117 is substation. A substation is an assembly of electrical equipment in one place that is used for converting or transforming electrical energy or for connecting two or more circuits. Measurement transformers and protection transformers are not considered transformers for this definition. Clause 1.4.118 is supply alternative. This is a supply system intended to keep part or all of an installation functioning if the normal supply is interrupted. Clause 1.4.119 is supply normal. This is the source of supply that the installation is normally supplied from under normal operating conditions. The normal supply is usually from a distribution network but may come from a generator. Clause 1.4.120 is supply supplementary. This is a supply system intended to operate together with the normal supply. Clause 1.4.121 is switchboard. A switchboard is an assembly of circuit protective devices, switchgear, instruments, or connecting devices, arranged for distribution and control of one or more submains or final subcircuits, or a combination of both. Clause 1.4.122 is switchboard, main. The main switchboard is the switchboard from which the supply to the whole electrical installation is controlled. Clause 1.4.123 is switchgear. This is equipment used for controlling the distribution of electrical energy, or for controlling or protecting circuits, machines, transformers, or other equipment. Clause 1.4.124 is touch current. This is electric current that passes through a human or animal body when the body touches one or more accessible parts of electrical equipment or an installation, under normal or fault conditions. Clause 1.4.125 is touch voltage. This is the voltage that appears between parts that are accessible at the same time. The term is used only in connection with fault protection. Clause 1.4.126 is track system. A track system is an enclosed wiring system where conductors are spaced or supported on insulating material within a channel, and where plug-in facilities exist along its length. This definition does not apply to busbar trunking systems that comply with ASNZS 61439.6. Clause 1.4.127 is trunking, cable. Cable trunking is a ductile trough used to house and protect electrical cables and conductors. Clause 1.4.128 is voltage. Voltage is the difference in potential between conductors or between conductors and earth. It includes Item A. Extra low voltage, which does not exceed 50 volts AC or 120 volts ripple-free DC. Item B. Low voltage, which is more than extra low voltage, but not more than 1000 volts AC or 1500 volts DC. Item C. High voltage, which is any voltage above low voltage. Clause 1.4.129 is wiring, catenary. This is a wiring system where a cable or cables are attached at intervals to a supporting wire that is suspended between 2 points. Clause 1.4.130 is wiring enclosure. This is a pipe, tube, duct, conduit, or cable trunking that is fixed or supported in place to house or protect sheathed or unsheathed cables. Clause 1.4.131 is wiring equipment. This includes all wiring of an appliance or electrical equipment that provides supply terminals for connection to an installation. Clause 1.4.132 is wiring installation. This is wiring whose cables are fixed or supported in place following the requirements of the standard. Clause 1.4.133 is wiring systems. A wiring system is an assembly of one or more conductors, cables or busbars, along with the parts needed to secure and protect them, including mechanical protection if required. Clause 1.4.134 is wiring, underground. This is a system of wiring where cables are buried directly in the earth or carried in an enclosure below ground level, and installed according to the requirements of the standard. That brings us to the end of Clause 1.4, which is the complete definitions section. From here, the standard moves into the more detailed rules of electrical installation practice, and we now have all the terminology needed to understand the rest of ASNZS 3000, 2018 clearly and confidently. Clause 1.5, Fundamental Principles. Clause 1.5 explains the core safety principles of ASNZS 3000. These principles guide the whole standard. They set out what we must achieve to keep people, livestock, and property safe from the dangers that can arise from electrical installations. Clause 1.5.1, Protection against dangers and damage. Clause 1.5.1 tells us that an electrical installation must protect against three main types of risk. The first risk is shock current. Shock current is the current that can flow through a person or an animal when they touch parts that are live in normal service, which is called direct contact, or touch parts that only become live under fault conditions, which is called indirect contact. Either situation can lead to serious harm, so the installation must be arranged to protect against both types. The second risk is excessive temperatures. Excessive temperatures can cause fires, burns, or other damage. People, equipment, and nearby materials must be protected from heat produced by electrical equipment, whether the heat comes from normal operation, fault conditions, or thermal radiation. The standard highlights three effects we must prevent: combustion or degradation of materials, risk of burns, and any reduction in the safe function of equipment. The third risk is explosive atmospheres. In areas where explosive gases or dust might be present, equipment must provide protection against the ignition of those gases or dusts. The installation must be suitable for the specific hazardous environment. Clause 1.5.2, Control and Isolation. Clause 1.5.2 explains that every electrical installation must include control and isolation devices. These devices must prevent or remove hazards so the installation can be used safely and can be maintained safely. Control devices must be arranged so that they do not interfere with the operation of any other equipment, and they must not be affected by other equipment accidentally. An isolation device must be able to disconnect all active conductors, and depending on the situation, may also need to operate in a neutral conductor. This isolation must remove the supply from all external sources. The standard reminds us that a device used for isolation must not interrupt an earthing conductor, or a combined protective earth and neutral conductor. Clause 1.5.3, Protection against electric shock. Clause 1.5.3 covers the key requirement. The installation must protect people and animals from shock current that may arise from contact with live parts under normal conditions, or with parts that only become live under fault conditions. Live parts must not be accessible without the use of a tool or a key under normal conditions or under a single fault condition. Clauses 1.5.4, 1.5.5, 1.5.6, and 1.5.7 explain the detailed requirements for basic protection and fault protection, and how these apply in different environments, including damp situations. Clause 1.5.3.2, Methods of Protection. Protection is provided in different ways depending on the situation. Under normal conditions, protection is usually provided by basic protective provisions. Under fault conditions, protection is provided by fault protective provisions. Enhanced protection, such as extra low voltage or reinforced insulation, can provide both basic and fault protection under all conditions. A method of protection must be either an appropriate combination of basic and fault protection, or an enhanced method that provides both. Some locations need additional protection because of environmental influences or special installation conditions. Different methods of protection used on the same installation must not interfere with each other. Failure of one method must not compromise another. Clause 1.5.4, Basic Protection. This part of the standard explains how we protect people from touching live parts during normal service. So, in simple terms, this is all about stopping accidental contact with live electrical components that are energized during day-to-day operation. Clause 1.5.4.1 General. Protection must be provided wherever there is any danger from touching live parts. These are the parts of an installation that are normally energized, and the protection has to make sure people, livestock, and property stay safe under normal conditions. Clause 1.5.4.2 Methods of protection. Basic protection can be achieved by one or more of the following methods. Method 1. Insulation. Covers live parts completely with electrical insulation that can withstand mechanical and environmental stresses, and the insulation must only be removable by destruction. Method 2. Barriers or enclosures. Live parts are placed behind barriers or inside enclosures that meet certain degrees of protection, such as IP2X, IP2XB, or IP4X for horizontal surfaces. The idea is simple: you should not be able to touch live parts unintentionally. Method 3. Obstacles. Obstacles prevent accidental contact with live parts. They are not designed to stop deliberate actions, but they help prevent an accidental bump or touch. Method 4. Placing out of reach. Live parts are positioned far enough away that a person cannot reach them from a normally occupied position. Remember, RCDs are not recognized as a sole means of basic protection. They can support these methods, but they cannot replace them. Clause 1.5.4.3 Protection by insulation. All live parts have to be fully covered with insulation strong enough to withstand stress in normal service. This insulation must comply with the relevant standard for the equipment. Manufacturers will already provide the correct type of insulation, so for commercial equipment, we simply follow the manufacturer's requirements. Paints and varnishes on their own do not count as proper insulation unless they are part of a certified system. Clause 1.5.4.4 Protection by barriers or enclosures. Live parts must be inside something that gives a defined degree of protection. For example, IP2X or IP2XB, meaning a finger cannot reach the live parts. IP4X for horizontal top surfaces people can touch easily. The barrier or enclosure must suit the environment and be strong enough to prevent distortion or damage that could expose live parts. Removal of barriers or covers should not be possible without using a tool or a key, except in controlled conditions. If barriers are removed, interlocking devices or intermediate barriers may be required to automatically keep people away from live parts. Clause 1.5.4.5 Protection by obstacles. Obstacles are used only where access is restricted to competent persons or people under supervision of a competent person. Obstacles can prevent accidental contact with live parts, but they are not intended to stop intentional contact. Examples are mesh guards, rails, or screens that block casual access. Obstacles may be removable without a key or tool, but they must be secured so they cannot be accidentally displaced. Clause 1.5.4.6 Protection by placing out of reach. This method relies on ensuring the live parts are positioned far enough away that a person cannot physically reach them from a normal working or standing position. It can only be used where access is restricted to competent persons or people under supervision. Simultaneously accessible live parts of different voltages must not be within arm's reach. Arm's reach means a radius of 2.5 meters from where a person is standing or can move within the space, including vertical reach. If obstacles or working conditions change the normal reach area, then distances must be increased to keep live parts safely out of reach. Clause 1.5.5 Fault protection. In this clause, we talk about what happens when a fault makes metal parts become live. If that happens, a person touching the metal could get a shock, so the standard requires us to put protection in place. The idea is very simple: if a fault can make something dangerous, the installation must have a method that keeps people safe. Every part of the installation must use a method that suits the equipment and the surrounding conditions. Clause 1.5.5.1 General. This clause explains the purpose. Whenever there is a chance that exposed metal might become live because of a fault, we must have protection. The method we choose depends on the environment and the equipment, but the goal is always the same: prevent electric shock under fault conditions. Clause 1.5.5.2 Methods of protection. There are several ways to protect people when a fault happens. The most common way is to automatically disconnect the supply. This means if a fault occurs, the protective device trips fast enough so the fault cannot hurt anyone. Another way is to use Class 2 equipment, or equipment with reinforced insulation. This means the live parts are designed so they cannot be touched, even if something goes wrong inside the equipment. A third method is electrical separation. This is normally done with a transformer that separates the output from earth, so there is no shock path if a single fault happens. The last method is limiting the fault current. In other words, if the design ensures the fault current is too small to be dangerous, then the risk of shock is very low. But in everyday electrical installations, automatic disconnection is by far the method we use the most. Clause 1.5.5.3, Protection by automatic disconnection of supply. This clause goes deeper into how automatic disconnection works. The main idea is that if a fault happens, the touch voltage rises on exposed metal parts. We need to limit that voltage and we need to cut off the power quickly. To do this, all exposed metal parts are bonded together and connected to earth. This keeps the metal at the same voltage, which reduces the shock risk. Next, a protective device, like a circuit breaker, a fuse, or an RCD, must disconnect the circuit fast enough. If the touch voltage becomes unsafe, the device automatically trips and removes the supply. For this to work properly, the earth fault loop impedance must be low. That means the fault current must be high enough to operate the protective device within the required time. The standard also gives maximum disconnection times. For example, some circuits must disconnect within 0.4 seconds, especially socket outlets and handheld equipment. Other circuits, like fixed equipment, are allowed up to 5 seconds. Sometimes extra bonding is needed if there is metalwork around the area, just to make sure the protective device can operate within the correct time. Clause 1.5.5.4 explains that one way to protect people from dangerous voltages is to use Class 2 equipment, or equipment with equivalent insulation. This simply means the equipment has double insulation, or reinforced insulation, so even if one layer fails, another layer still keeps you safe. Sometimes total insulation is built into switchgear, and sometimes extra insulation is added during installation. The key idea is that strong insulation stops fault voltage from reaching metal parts a person can touch. If extra insulation is added on site, it must be fitted properly. There should not be any metal screws or bolts that break through that insulation. Any covers or lids that can be opened without tools must still keep live parts safely behind an insulating barrier that meets the correct IP rating. Clause 1.5.5.5 is about electrical separation. Electrical separation means using an isolated transformer to supply one individual circuit. Because the active and neutral are not connected to earth anywhere, there is no return path through earth if a person touches one live part. This reduces the risk of electric shock. But this only works if the separated circuit stays completely isolated. It cannot be earthed, bonded, or connected to any other circuit. Clause 1.5.6 introduces extra protection by the use of RCD devices. RCDs are not allowed to be the only method of basic protection, but they are very useful as extra protection on top of insulation and barriers. Clause 1.5.6.1 says that an RCD can support basic protection, but it cannot replace the normal basic protection such as insulation. It is simply an extra safety layer. Clause 1.5.6.2 explains that RCDs are acceptable for fault protection. If a fault causes current to flow to earth, the RCD detects the imbalance and switches off the supply quickly. This reduces the chance of electric shock in a fault situation. Clause 1.5.6.3 explains where RCDs must be installed. They are required for socket outlets, lighting points, handheld equipment, and many wiring systems. They are also required for heating cables, equipment used in damp areas, and several special installations covered by ASNZS 3001, 3002, 3003, 3004, 3102, and 4249. The message is simple. Where the risk of electric shock is higher, an RCD must be used. The purpose of the RCD is to disconnect the supply fast enough to prevent serious harm. Clause 1.5.7, Basic and fault protection by use of extra low voltage. This clause explains how SELV systems, or PELV systems, can be used to provide both basic protection and fault protection, but only when certain conditions are met. First, the nominal voltage must never exceed the limits for extra low voltage. That means no more than 50 volts AC, or 120 volts ripple-free DC, even if the supply is arranged in different ways. Second, all circuits must be electrically separated from each other, and separated from any higher voltage circuits. Third, live parts of SELV circuits must never be connected to earth, or connected to protective earthing conductors, or to live parts from any other circuit. Fourth, for PELV circuits, live parts must be protected against direct contact. This can be done by barriers or by insulation, unless the voltage is extremely low. In dry areas, this limit is 25 volts AC or 60 volts ripple-free DC. Where a person may have a larger contact area with the body, such as wet or conductive locations, the voltage limit is 6 volts AC or 15 volts ripple-free DC. Clause 1.5.8, Protection against thermal effects in normal service. This clause deals with preventing fires caused by heat from electrical equipment. Electrical installations must be arranged so that high temperatures, electric arcs, or other heating effects cannot ignite flammable materials. Equipment must be installed so its temperature characteristics, during normal use, do not create risk to people, to livestock, or to property. Heat produced in normal service must not cause damage to the equipment itself, or to adjacent materials, or to any other installation. If heat is expected, adequate ventilation must be provided to keep temperatures within safe limits. The standard reminds us that temperature can affect the performance and lifespan of electrical equipment, so installation choices must take this into account. Clause 1.5.9, Protection against overcurrent. This clause explains that protection must be provided to prevent injury or damage from excessive current. Overcurrent can create dangerous temperatures or mechanical stress in conductors and equipment. Protection may be provided by one of two methods. 1. Automatic disconnection of supply before the overcurrent reaches a dangerous level. 2. Limiting the overcurrent to a safe value and safe duration. Clause 1.5.10, Protection against earth fault currents. Any earthing conductor, and any other part of the system that must carry an earth fault current, must be capable of carrying that current without being damaged. This ensures the protective device can operate safely during an earth fault. Clause 1.5.11, Protection against abnormal voltages. This clause covers protection against harmful effects of abnormal voltages. These can come from several sources: faults between live parts of circuits supplied at different voltages, induced voltages in unused conductors, or harmful influences between different circuits and installations. Clause 1.5.11.1, General. Protection must be provided for any harmful effects of abnormal voltages that may arise from faults between circuits of different voltages, voltages induced or occurring in unused conductors, or harmful influences occurring between different installations or between electrical and non-electrical systems. Clause 1.5.11.2, Circuits operating at different voltages. This clause explains that protection must be provided to prevent injury or property damage if a fault occurs between live parts of circuits that operate at different voltages. Two methods may be used. The first method is segregation, keeping the circuits physically separated from each other so a fault cannot jump between them. The second method is installing devices that protect against overvoltage. These devices help limit or prevent dangerous voltages if a fault occurs between the circuits. Clause 1.5.11.3, Voltage disturbances and electromagnetic influences. This clause states that protection against damage from overvoltage caused by events such as lightning, or caused by switching operations, is not a requirement of this standard. However, it points readers to guidance in Clause 2.7 in Appendix F, which explain how to manage surge protection if it is needed. Even though surge protection is not mandatory here, it may still be required in other standards or for sensitive equipment. Clause 1.5.11.4 Voltage in unused conductors. This clause explains that unused or disconnected conductors can still develop dangerous voltages. For example, an unused conductor running beside a high-voltage cable can pick up induced voltage, even if it is not connected at either end. To prevent injury or property damage, any disconnected, redundant, or unused conductor that remains installed must be terminated and protected at both ends in the same way as a live conductor. The key idea is that unused conductors must never be left floating, because they can still become energized due to induction or other effects. Clause 1.5.11.5 Different circuits and installations. This clause explains that protection must be provided against harmful influence between different types of circuits or different installations. This includes 4 situations. First, influence between 2 separate electrical installations. Second, influence between different circuits within the same installation. Third, influence between electrical circuits and non-electrical systems. And fourth, influence between the electrical installation and the structure of the building or the land that the installation is mounted on. There are also notes reminding us that telecommunications cables near high-voltage systems must follow the requirements of other standards, and that ASNZS 3800 gives additional guidance on managing electrical interference between circuits, including for data and communication systems. Clause 1.5.12 Protection against the spread of fire. This clause explains that electrical installations must not start a fire, and must not help a fire to spread. Electrical equipment must be selected, installed, and protected so that it does not block escape routes, does not produce smoke or gases that obstruct people, does not add fuel to a fire, and does not reach temperatures that could ignite nearby materials. It also must not interfere with people escaping from a structure. Clause 1.5.13 Protection against injury from mechanical movement. This clause deals with moving parts of electrically driven equipment. Protection must be provided wherever maintenance work could expose someone to injury, or where emergency stopping may be needed to prevent harm. This protection can include devices that disconnect or isolate equipment to remove the mechanical danger. Clause 1.5.14 Protection against external influences. Here the standard explains that all parts of an electrical installation must be protected against the conditions they may face in normal service. This includes mechanical damage, weather, water, dust, corrosive chemicals, vibration, animals, temperature, explosive atmospheres, and other environmental factors. The installation must be able to withstand these conditions without becoming unsafe. Clause 1.6.1 General. An electrical installation must be designed to keep people, animals, and property safe. It must work properly for its intended use. It must connect and operate safely with the electricity supply it is attached to, and it must not create problems for the distribution system. It must allow safe operation, safe inspection, safe testing, and safe maintenance. And it must reduce inconvenience if a fault happens. Clause 1.6.2 Supply characteristics. When planning or designing an installation, we must know the important details of the electricity supply. We need to know whether the supply is alternating current or direct current. We need to know how many conductors are provided, including phase, neutral, and protective earth for an AC supply. We need to know the voltage and the tolerance. For New Zealand, the nominal low voltage supply is 230 over 400 volts, plus 6% and minus 6%. We need to know the frequency, the maximum current available, and the possible short-circuit current. We also need to know what protection measures are present in the supply system, such as the main earthing system. And finally, we must understand any limits on equipment use, including harmonic levels and other characteristics that might affect the design. Clause 1.6.3 Maximum demand. The maximum demand of an installation must be determined. This means working out how much electrical load the installation will need, where the load is located, and how the load may change depending on how the installation is used. Clause 1.6.4 Utilization voltage. The installation must be designed so that the voltage at the appliances and equipment is suitable for their proper operation. This includes considering voltage drop. Clause 1.6.5 Circuit arrangement. Circuits must be arranged to reduce danger and reduce inconvenience when a fault occurs. They must also allow safe operation, inspection, testing, and maintenance. Clause 1.7.1 General. Electrical equipment must be selected and installed so that it operates safely and reliably under normal conditions. It must not create danger from shock, fire, overheating, or other reasonably expected conditions such as overload or external influences. And the equipment must be installed according to both the requirements of this standard and the manufacturer's instructions. Clause 1.7.2 Installation work practice. Electrical equipment must be installed using safe and sound work practices. This includes choosing equipment that is strong enough, durable enough, and suitable for the environment. Installation instructions must be followed. Safe access and working space must be provided. Fixings and supports must be strong and reliable. Installation wiring must be clearly identified. Active, neutral, earth, protective earth, and equipotential bonding conductors must be shown correctly. Green or green and yellow are only for earthing and bonding conductors. Live conductors must not use green or green-yellow. Socket polarity must match the product specification and be consistent across the installation. Semi-enclosed rewirable fuses must not be installed. Condensation control must be considered where required. And equipment must be installed in a way that keeps its IP rating. Clause 1.7.3 Equipment selection. Electrical equipment is considered suitable if it meets the safety requirements in ASNZS 3820, or if it complies with the appropriate Australian, New Zealand, or international standard that applies to that type of equipment. Clause 1.7.4 Damp situations. Electrical equipment used in damp or wet locations must be suitable for the environment, must provide extra protection against shock, and must protect against damage caused by moisture or high humidity. Clause 1.8 Verification. Before an electrical installation, or any alteration or repair, is placed into service, it must be inspected and tested as far as practicable to confirm that it meets the requirements of ASNZS 3000. The inspection must avoid danger to people and avoid damage to property. If the work is an extension or alteration, it must also be checked to confirm that it does not reduce the safety of the existing installation. The correct connection of conductors to control and protective devices must be verified. Clause 1.9 Means of compliance. This clause explains the different ways an installation can show it meets the safety principles in Part 1. It tells us when we can rely on Part 2, when other standards may apply, and how changes or special designs must be handled. Clause 1.9.1 Compliance with Part 2 of this standard. If an installation follows all the rules in Part 2, then it is considered to automatically meet the safety principles in Part 1. That is the default pathway. In New Zealand, this does not apply to domestic installations. Clause 1.9.2 Compliance with other standards. Some installations need to follow extra standards that apply to their specific type of equipment or environment. This clause simply reminds the designer to check which additional documents are required. Clause 1.9.3 Alterations and repairs. When you change or fix an installation, the new work must not make anything less safe. You cannot leave any part carrying more current or voltage than the standard allows, and you cannot create conditions that break the rules. Repairs should use materials and methods that were acceptable for the original installation, but they must still meet today's safety expectations. Clause 1.9.4 Compliance by specific design and installation. Sometimes an installation cannot follow Part 2 step by step. In those cases, a specially designed solution may be used, as long as it still achieves the same level of safety required by Part 1. Clause 1.9.4.1 Use of a Part 1 design. A special design is acceptable only if it clearly provides a safe outcome. The installation must still protect people from shock, fire, and other hazards, even though the design does not follow Part 2 exactly. Clause 1.9.4.2 Acknowledgement by the owner or operator. If a design does not follow Part 2, the owner must formally acknowledge this so everyone understands the approach and the safety decisions taken. Clause 1.9.4.3 Documentation by the designer. The designer must record the reasons for not using Part 2, the checks needed to make sure the installation is safe, and any special instructions. This documentation shows how the design meets the aims of Part 1. Clause 1.9.4.4 Verification. Before the installation is used, all parts covered by the special design must be tested and inspected to confirm they actually meet the required safety level. Clause 1.9.4.5 Competency requirements of designers. Anyone creating a design that departs from Part 2 must be competent and able to understand the risks involved. Clause 1.9.4.6 Identification. Any switchboard connected to a special Part 1 design must have a clear and permanent label stating that the installation uses a Part 1 solution under ASNZS 3000. This ensures future workers know exactly what type of design they are dealing with. We have now reached the end of Part 1 of ASNZS 3000. This section has laid out the fundamental principles that guide every electrical installation, the purpose, the scope, the definitions, the protective measures, and the essential requirements for design, selection, installation, and verification. Part 1 gives us the framework. It explains why we do things a certain way, what risks we must manage, and how safety, reliability, and compliance are built into every decision. From understanding shock current and external influences, to selecting the right equipment, to ensuring installations are inspected and tested before use, these principles support everything we do in the field. As we move into Part 2 and the standard, the focus shifts from principles to detailed rules and technical requirements. Part 2 shows us how to apply what we have just learned, turning these safety principles into practical installation methods. Thank you for listening to Part 1 of ASNZS 3000. Let's continue with Part 2, where we look at the specific installation rules that bring these principles to life in real electrical work.